Let's explore why face-centered cubic, FCC, and body-centered cubic, BCC, crystal structures have different atomic packing factors. The atomic packing factor, or APF, is the ratio of the volume occupied by atoms to the total volume of the unit cell. We can express this mathematically as the volume of atoms divided by the unit cell volume. Let's first look at the face-centered cubic structure. In FCC, we have atoms at each corner of the cube and at the center of each face. When we count the atoms, we get 4 total, 1/8 of each corner atom, since it's shared by 8 unit cells, plus half of each face atom, since it's shared by 2 unit cells. For FCC, we can calculate the APF using the relationship between the atomic radius and the unit cell edge length. The edge length is equal to 4 are divided by √2, where r is the atomic radius. When we plug this into our formula, we get an APF of 0.74, or 74%. Now let's look at the body-centered cubic structure. In BCC, we have atoms at each corner of the cube and 1 atom at the center. When we count the atoms, we get 2 total, 1/8 of each corner atom, plus the 1 center atom. For BCC, the edge length is equal to 4 are divided by √3. When we calculate the APF, we get 0.68, or 68%. The FCC structure has a higher packing factor because it has more atoms per unit cell, and they're arranged more efficiently. In FCC, each atom has 12 nearest neighbors, while in BCC, each atom only has 8. This is why many metals prefer the FCC structure. It allows them to pack more atoms into the same space, minimizing the overall